In the present video, we will discuss the quantitative forecasting methods. Before discussion of the quantitative methods, we will discuss the measures of forecast accuracy. Forecasting affects many decisions in different departments of a company. Therefore, forecast should be as accurate as possible. To check how accurate a forecasting method is, some error measures are used. These errors show the difference between the actual demand and forecasted demand. The commonly used measures of forecasting accuracy are: first one is the mean absolute deviation, second one is mean square error, third one is mean forecast error, fourth one mean absolute percentage error, fifth one is tracking signal. So the forecast error is calculated by ET equal to the DT minus FT, where ET is the forecast error during period T, DT is the actual demand during period T, FT is the forecasted demand during period T. Next we will discuss the mean absolute deviation, that is MAD. Mean absolute deviation is the average of the absolute differences between the forecasted demand and the actual demand values. So mean absolute deviation is also called mean absolute error. So mean absolute deviation equal to summation of T equal to 1 to n absolute dt minus ft divided by n, where dt is the actual demand for period t and ft is the forecasted demand for period t, and small n equal to the number of time periods are using. So mean absolute deviation is the shows the size of forecasting errors made in each period without considering whether the error is positive or negative. So the errors are taken in absolute values only. So let's see the one small example. So there are the 3 time periods are given along with the actual demand dt and forecasted demand ft. So first we will find out the error, which is equal to the dt minus ft. So for the first time period, dt is the 250 and ft is the 240. So 250 minus 240, which is equal to the plus 10. And for the error for the second time period, 250 minus 280, which is minus 30. For third one, 270 minus 250, which is equal to the plus 20. So mean absolute deviation is, we have to considering the errors only absolute values. So have to consider only positive values. Then mean absolute deviation, which is equal to the plus 10 plus 30 plus 20. So mean absolute deviation equal to the 10 plus 30 plus 20 divided by small n equal to the number of time periods, that is the 3. Then MAD equal to the, so 60 divided by 3, which is equal to the 20. Next we will discuss the mean square error, that is MSE. Mean square error is the average of the squared differences between the forecasted demand and the actual demand values. Small errors may not create serious problems because they can be managed using inventory or overtime work. But large errors can create major problems since the errors are squared. So MSE gives more importance to large errors than smaller errors. So MSE, mean squared error, equal to the summation of T equal to 1 to n dt minus ft whole square divided by n, where dt is the actual demand for period t and ft is the forecasted demand for period t, and n equal to the total number of errors or time periods are using. Next we will discuss the mean forecast error or bias. Mean forecast error is the average of the forecast errors. So it shows whether the forecast are generally higher or lower than the actual demand. So mean forecast error MFE equal to the summation of t equal to 1 to n dt minus ft divided by n. So mean forecast error measures the forecast error with respect to direction and shows whether there is a tendency of over forecasting or under forecasting. If a positive bias indicates under forecasting and a negative bias indicates over forecasting. And next we have to see running sum forecast error RSFE, which is equal to the summation of t equal to 1 to n dt minus ft. And similarly bias equal to the RSFE divided by small n, where small n equal to the number of time periods or years are using. Next we will discuss the mean absolute percentage error MAPE. Mean absolute percentage error is the average of the percentage errors between the actual demand and the forecasted demand. So mean absolute percentage error shows the forecasting error in percentage form. So mean absolute percentage error MAPE equal to the 1 by n into summation of t equal to 1 to n absolute dt minus ft divided by dt into 100. And next one is the tracking signal TS. Tracking signal is the RSFE divided by MAD, where RSFE is the running sum forecast error and MAD is the mean absolute deviation. Tracking signal is used to check how well the forecast predicts the actual demand values. An ideal value of tracking signal is 0, but a small value between +4 and -4 or +5 and -5 is generally considered the acceptable range. If the tracking signal goes beyond this range, it indicates that the forecasting process may be out of control. So this is the summary of the different types of the errors. So next we calculate the different errors such as the mean absolute deviation, mean square error, mean forecast error and mean absolute percentage error for the following data. So let's consider the data is here. Time period is the 1, 2, 3, 4, 5 and given the demand dt and forecast ft for the respected time periods. So first we will calculate the mean absolute deviation. We know that mean absolute deviation equal to the summation of t equal to 1 to n absolute dt minus ft divided by n. So first we have to calculate the deviation, that is dt minus ft. So for the first time period dt minus ft 150 minus 165, it is the minus 15, and for the next time period 160 minus 165 minus 5, and next one 165 minus 165 0, and for the next one 175 minus 165 plus 10, and next one is the 180 minus 165, it is also plus 15. So next we have to calculate the absolute deviation, that is the absolute of dt minus ft. So in the deviation we have to consider all the positive only. Then absolute dt minus ft for the first time period it will become the plus 15, and for the next one plus 5, and next one is the 0, and next one 10, and next one is the 15. So then summation of this absolute dt minus ft is the 15 plus 5 20 plus 0 20, so 20 plus 10 30, 30 plus 15 45. So MAD value is the 45 divided by small n equal to the 5. So 45 divided by 5 which is equal to the 9. Next we will calculate the mean square error MSE. We know that when the MSE equal to the summation of t equal to 1 to n dt minus ft whole square divided by small n. So here we know the dt minus ft values for the each time period. Then we have to determine the squared error dt minus ft whole square. So it is the for the first time period. So minus 15 whole square which is equal to the 225 and minus 5 whole square 25, 0 square which is equal to the 0, 10 square it is the 100, 15 square which is equal to the 225. So next we have to determine the summation of these squared error. So which is equal to the 225 plus 25 plus 0 plus 100 plus 225 which is equal to the 575. Then MSE equal to the 575 divided by 5 which is equal to the 115. Next we will calculate the mean forecast error. We know that mean forecast error MFE equal to summation of t equal to 1 to n dt minus ft divided by n. So here not absolute error, we have to consider the only deviation. So MFE equal to the deviation for the first time period is the minus 15, next one is the minus 5, next one 0 and next time period 10 and next time period is the 15. So MFE equal to the summation of so minus 15 minus 5 plus 0 plus 10 and plus 15 divided by 5. So here so minus 15 plus 15 it will be cancelled and minus 5 plus 10 which is equal to the plus 5. Plus 5 divided by 5 which is equal to the plus 1. Next we will calculate the mean absolute percentage error which is equal to the 1 by n into summation of t equal to 1 to n dt minus ft divided by dt into 100. So first I have to calculate the absolute percentage error, that is absolute of dt minus ft divided by dt into 100. So here we know the absolute deviations. So that is absolute dt minus ft values we know and divided by dt into 100 we have to determine for the each time period. So for the first time period, so 15 divided by dt is the 150. So 15 divided by 150 into 100 which is equal to the 10 and next one is the 5 divided by 160 into 100. So 5 divided by 160 into 100 which is equal to the 3.125 and next time period absolute percentage error is the 0 and for the next one is the so 10 divided by so dt value is the 175. So 10 divided by 175 into 100 which is equal to the 5.71 and for the next one so 15 divided by 180. So 15 divided by 180 into 100 which is equal to the 8.33. So next we have to determine the summation of absolute percentage error which is equal to the 10 plus 3.125 plus 0 plus 5.71 plus 8.33 which is equal to the 27.165. Then mean absolute percentage error equal to the 27.165 divided by 5 which is equal to the 5.433 percentage. So this is the calculation of different errors and thank you.